Hello everyone, in this video we are going to discuss that if a single linked list given to us, how we can reverse a single linked list. So suppose a single linked list is given like this. We know the structure of singly linked list. Every node it is having two part. The first part it is the data part, and the second part it is the address of the next node, which is pointing to this particular next node. So you can see that every node is having two parts, and here this linked list is consisting of total four nodes within it, where the data parts are given as 10, 20, 30, 40. So whenever we are trying to execute the C program for reversing a single linked list, so normally when we are traversing single linked list, it will print the data value as 10, 20, 30, 40. So which are starting from first node to the last node. But after reversing a single linked list, we are expecting the output which is starting or displaying the values from the last node. That is, it will print as 40, 30, 20 and 10. So the objective of doing this is that if a linked list is given to us, whichever the data part which are being printed from forward to backward, instead of printing from forward to backward, we want to display the data part from backward to forward, and like this. So I will be just quickly taking the help of diagrams to explain this particular concept. So like every linked list, like a single linked list, every node is having the two parts, and we are taking every time this linked list the links which are pointing to the next node. So the very first thing is that here, if you can see this particular diagram which is having four nodes, what we need to do, we need to focus on these links. We have to remove these links. We know that the last part of this next part of the last node is always being pointed to the null. So we have to remove these links. So whichever these links are, you as you can see that they are pointing to the next node, we want to revert back this linked list which they should not point, the node should not point to the forward node, it should always point to the backward nodes. The very first thing is that we have to remove these links. We have to remove these links. And the very first thing is here that whichever the first node in our linked list is there, that we can just show it as a start node, which is the starting address of our linked list, which is very important, because with the help of the start address you can traverse the complete linked list from first node to the last node. So what we need to do, the start node which is given in our linked list, that start node we want to make the next part of this start node as null. So as like you cannot make the start nodes next part as null, because if you will do that, you will not be able to get the connection with the remaining nodes in your linked list. So what you are trying to do here, you will put this start node, you will make this second node as the start node, and you will make this first node as a previous node. And once you have made this first node as a previous node, you will make this next part of this previous node as the null. So I will be just taking the first step here. So I will be just taking the step number one, what we are going to do. So I will be taking the same diagram. This is the same linked list I'm talking about. So this is my step number one. In step number one, we will make this particular node as first node as the previous node here, and then we can make the next node as the current node. So you can see here that this first node, we have made this first node as the previous node, right? So this is our previous node, and now this is our current node. And I have shifted this start node again by one, so our start is not now this start it will be pointing to the next node here. So this second node, it will be our start node now. Okay, so we have just changed the status of the linked list. As the first node, we have moved the start by one, that is start equals to start of next. We have made this first node as the start, then we have moved this start by one, and then we make the current node as start. So by, like, whenever we are writing the program for this, the very first three steps that we need to follow here is that we have to make the start node as previous, and that we can make it like this: previous equals to start. This will be our first step. Second step is that, as you can see here, we have made the second node as the start node. So if first node is as the start node, the next node, that is start of next, it will become your new start node. So you will be just writing here start equals to start of next. And then once you got your start node, you made that particular node as the current node by writing as current equals to start. So in the step number one, if you can observe, we have done three things. The very first thing is that we have made the start node as the previous by writing the statement as previous equals to start. Then whichever our start node was there, that I have shifted by one, so it will be start equals to start of next. And once you got start, I have made the start node as the current node by writing current equals to start. So as you can see now, the step one is not in step one, your first node is not the start node, so you can make this previous part of the first node as the null. So the second step that we are going to take here is that the second node, I will be taking out the same linked list here. So you can see here that the first part, this previous and current, they will be as it is pointing here. So this is our previous and current, and only what the change I'm doing here, I will be removing this link. I will not taking this link, and I will be just removing this link out from this, and I will be making this next part of the previous node as null. So that is possible when you are writing the statement as here previous of next equals to null. So whenever we want to whenever we want to reverse this particular linked list, then we have to make the first node's next part as null. So first node, it was previous, and now you have make the previous next part as null. So you have carried out total four steps here. The very first step is that you have made the start node as the previous by writing previous equals to start. Then you have shifted the start node by one by writing start equals to start of next. And then you have made the complete start node as current by writing current equals to start. So once you have performed these three steps, now you can see that the first node is not your start node, it is previous node. So you can just make the previous of the next as null, because while reversing the singly linked list, we want the last node as the first node and the first node as the last node. So we are making the first node's next part here as null. So these two steps we have yet performed. We have till performed. So I will be moving to the next step now. That is step number three here. In step number three, what we are going to do, whichever the link list is given to us. So this was the link list. So I will be taking the same link list, and I'm just assuming that this particular next part I'm going to remove. So you have already understood that this next part is not there. This is our null part that you have already make here. And then what we are going to do in third step, which was our start, it was our previous node, right? This was our previous node. So instead of writing complete previous, I will be just taking the abbreviation as P. Then this was our current node, and it was our start node. Now what I will be doing, I will be repeating the steps from this particular step number three. So in step number three, I am writing one important statement here, and that statement is start equals to start of next. Start equals to start of next. So by writing this, previously our start was this was our start, right? But now when I'm writing this start equals to start of next, this start, it will be shifted to by shifted by 1. So you can see here. So you can see that I'm talking about the three pointers at a time. This is previous, this is current, and this is start node. Right. So once you have made this next part of the first node as null, you have moved the start. Your next target is that you have to remove this link. You have to remove this link. For removing this link, again you are using the same logic. You make this current node as the previous node, you make this start node as the current node, then you will be able to take this second link to the back to the first one. So I will be talking about the step number 4 now. So this is your step number 4. So in step number 4, what we are going to do, I'll be again taking this linked list. So what is the logic now in step number 4? Whichever the node is there, what is your objective? You want to remove this link. So for removing this link, what you are going to do, whichever the current's next part, so this current next part, it should point to the previous. So if I'm writing the statement here that current equals to current of next equals to previous, so what will happen, what the change will happen in this diagram is that this link will not be there. So this link is not there. This link we already have removed by making this next part as null. Now your current, this was your previous, it was your current, and then it was your start. So you have made current of next, that is this part. Current of next you have made, which is pointing to the previous by writing the statement current of next equals to previous. So you can see here that we have changed the link part of the first node, which was going from first to second, and now with the link which was going from second node to the third node, we have changed that link of the second node pointing to the first node by writing current of next equals to previous. Then when you are moving to the step number 5, so in step number 5, what we are going to do, we are doing the same thing. We will be changing the uh, mm, uh, previous, current, and start node here. So you can see in this diagram, again I will be taking the code like this. So the code is that previous equals to current. So we are making the current node as the previous node, and then you are making the start node as the current node by writing current equals to start. So these two major changes you are making. So which was our previous node? This was our previous node. This was our current node, and this was our start node. So after step number 5, what will happen, that this current node C, it will become the previous node by using this statement previous equals to current. And which was your current node? This was your current node that is being shifted by this start node. It will become your current node. So which was current will become previous, and which was start, it will become current. So by writing previous equals to current and current equals to start, and your start, it was already here. Right now, as you have already changed these links, this link, it is pointing to null now. You have removed this link in step number 4 by writing current of next equals to previous. So this link is like this now. Now your main objective is that you have to remove this link. So this link which is going from third node to fourth node, you have to make this link available from current node to the previous node. So what you are going to do, again you are going to shift the start by 1. So what you are going to do in step number 6, you will be just taking this start by 1. So you will be just writing down this as start equals to start of next. So what is the code that you are writing here? It will be just start equals to start of next. So it was your previous node. Observe step number 5. It was your previous node. Then it was your current node, and now this is your start node because you have shifted the start by 1. and this link you already have removed. So this link is already pointing to this node, and this node, it is like this, next part as the null. So we have completed this step number 6, and now this steps we are going to repeat. So step number 3 to step number 6, until the all nodes have been covered. All nodes will be covered at a step when there will not be address with start node. When your start node, it will be pointing to null, then you can say that you have to stop at this particular step. Then what we are going to do in step number 6, the next part is that you will be taking the same list again. Here you have to take, you have taken the same linked list. So step number 6, first step is over. In step number 6, the next step is that you already have done here. So which was your previous node? Previous node, it was your previous node, it was your current node, and it was your start node, and this link, it was null. So if it is null, then there will not be link between this node. Again, there is no link between this node, because this next part is being pointing to the previous node. And now what we have to do, we have to take this link we have to take in a backward direction. So again, we will be, what we are doing, we will be taking current of next. So this is current, and this is its next part, that should point to the previous. So again, you will be writing the same step again. We already have written here current of next. So current of next, it will be pointing to the previous. So what will happen by this particular statement? This next part, you are talking about the current next part, this is current, and this next part, it will be pointing to the previous now. So this is your previous. So every time what I'm trying to do, I will be repeating the steps. I will be repeating the step. First I will be moving the start by 1, start equals to start of next. Then I will make the current of next as previous, and then entire current node I will make it as a previous node, and entire start node I will make it as a current node. So every time you will be doing until your start, it will become null, right? So this is your step number 6. The in step number 6, it is step number 2. Then I will be going for the next step. So in next step, again you will be making your current node as the previous node, and start node as the current node. So how you are going to do that, what kind of coding statements you will require here? You will be just writing two lines here: previous equals to current, previous equals to current, and then you have to take it as current equals to start. So whenever you are writing this, what will happen? This particular node, your this node, this will become your previous node. This will become your previous node. It was current node first, and now your current node, it will be here only, and it was your start node again. Right, so you will be repeating these steps, and now you can see that your start is already at the last node, and the objective is that you have to make this node now, this link you want to point to the first node. So again, the same thing we are going to do. Current equals to, sorry, current of next equals to previous. So you can see here that this is current node, and its next part, it should point to the previous node. So again, I will be taking this diagram. This, there is no link, it was null, and then this node, it was pointing here, this node, it was pointing here, and now for the last step, the last node, that is the fourth node, it will be pointing to the third node. So how that is possible? So that is possible by writing only one statement. So that statement is current of previous, sorry, current of next, it will point to the previous. So what will happen here? So this next part, instead of this next part null, it will be pointing to this, because it was your previous and it was your current. So current of next equals to previous, it was your start node only, and then this was null, no link was here. This link is pointing to this node, and this node is pointing to this particular one. So you can see here that starting from the first node to the last node, what we have done, we have tried to maintain the three pointers. One is previous pointer, another is current, and third is start. Start is basically required in each and every linked list, because start, we are assuming that it is the address of the first node. Along with start, we have tried to maintain the previous and current. Every time the link which is going from first node to the next node, we are reverting that link back by making the arrangement in such a way that every time the current of next, it will be pointing to the previous node. And then again you will be doing the same thing, whichever this previous node is there, that will become current too. So you're following these two steps again. So again, this previous equals to current, so it will become your previous node. And then this start node, start equals to start of next, so this start will become null, this current will become null, because you can see that this is the last node. So you can see, once you are at this stage when your last node is previous node, in your program you have to just write down one statement, that whichever the previous node is there, you make that particular node as the start node. So how you can do that, you will be just writing here as start equals to previous, so you are making the previous node as the start node. So this simple statement means that this last node, the node which is having the data part as 40, that will be your first node in the linked list. So this will be your first node, then it will be your second node, then it will be your third node, and then it will be your fourth node. So you can see here that we have changed out the sequence which was going from first node to the second to third, and third to fourth, we have reverted back, making the first node as the last node by setting the null part of the first node whose data part as 10, and the last node, we are making that last node as the first node. So thank you for listening to this video. Thank you.